Solving multi-step equations, lesson 8, worksheet number 2. For questions 11 through 15, you're to determine if each of the following equations has one solution, no solution, or infinitely many solutions. If you remember, this is where you do the first two steps and then you stop. Now you don't have to write this down. I copied and pasted this from the notes. So this should be in your notes. So you're going to do the first two steps and stop. So like where I have it highlighted here, that's where you would stop. And then you determine if the variable terms are different, then it is one solution. If the variable terms are the same but the constant terms are different, then it is no solution. Or if everything is exactly the same, so the variable terms are the same and the constant terms are the same, then it's infinitely many solutions. So I'm going to do questions 12 and 14 with you. So like I said, you start with the first two steps. So I'm going to start with the distributive property. I'm going to distribute -4 and 2. All right, so bring down the 12a. -4 times 5a would be -20a. -4 times, that's a -1, would be +4. 2 times 3a would give me 6a. 2 times 6 would be 12. And bring down the -10a. After the distributive property, we combine like terms. So I'm going to combine 12a and -20a on the left side. On the right side, I'm going to combine 6a and -10a. So the constant terms on both sides do not have anything to combine with them. All right, 12a minus 20a would be -8a. Bring down the +4. 6a minus 10a, 6 minus 10 would be -4a. Bring down the +12. And that's where you stop. And then you ask yourself, you look at the variable terms first. If I look at this, I notice that my variable terms are different. The variable terms are different. So if I go down to my chart here, where does it say the variable terms are different? Right here. And if the variable terms are different, it's going to be a one solution problem. So knowing that my variable terms are different, say I've got a -8a and a -4a, they are different. Therefore, this is a one solution problem. And we're done. Make sure you have everything written down. For number 14, I'm going to do the distributive property. So I'm going to distribute 5. And -3. Right, 5 times 2y would be 10y. 5 times -6 would be -30. Bring down the -22y. Bring down the 10. -3 times 4y would be -12y. -3 times, that's a -2. Two negatives would make that +6. Now I combine like terms. I have 10y, oops, and -22y. Then I have -30. I have 10 and 6 as my constants on the right side. It does not want to circle, does it? There we go. And negative 12y on the right. So 10 minus 22 would give me negative 12y. Bring down the negative 30. Nothing to combine, excuse me, nothing to combine with the y term on the right side, so I bring down my negative 12y. And 10 plus 6 would be 16. All right, and that's where we stop. Let's look at our variable terms first. Our variable terms are the same. But if you look at your constant terms, the constant terms are different. So we want to find the solution where the variable terms are the same, but the constant terms are different. Well, here my variable terms are different, so it's not that one. Here the variable terms are the same, and the constant terms are different, so my answer is a no solution problem. So for number 14, my answer is no solution. Now remember, if everything is exactly the same thing on both sides, that is an infinitely many solutions. Exactly the same thing on both sides, it's an infinitely many solutions. Please be careful with your signs. If you have any questions on 11 through 15, please do not hesitate to ask.